When I was younger, I was a junk collector, and I would always see these strange machines, some black leatherette case with glass tubes inside, and they looked intriguing. And one day I bought one, and I wasn't sure what it would do. And I plugged it in, and it made a little bit of noise, but nothing much was evident. But the TV started flashing across the room. So I said, I better unplug the TV before I mess something up. And when I walked over, it had already been unplugged. So whatever this device was causing interference without wires. And I had no clue of what this technology could have been. And it turned out to be a 1930s shortwave diathermy machine. And I had looked up the company, tried to find information. There was nothing there. So I said, well, maybe I'll be the one to find out all the information. All of Tesla's early coils and his lecture coils, they were wound in the form of flat spirals, and they were embedded with beeswax and rosin. And these coils were much more efficient than the helix coils that you see today. And this is actually the secondary coil of one of them. It's multi-layers, wound flat, and this wire would be attached to the primary coil. This inner wire was the actual output of the secondary, which is where the sparks would come from. Normally there'd be a post and a ball on top. It's incredible that we see sparks today and think of Tesla coils as just something that makes a spark, but really there's a whole variety of different discharges that can be made with them. Tesla went on in his lectures in the 1890s describing how beautiful some of the effects were. And he showed all sorts of ionization of cones and of different shapes and of Geisler tubes and of Crookes tubes. And a lot of people just kind of read over those pages and say, yeah, it's kind of neat, but what use is it? And a small Tesla coil like this, certain varieties could be used to produce x-rays, to do surgery, to do treatments all in one. So you could have one machine that had many functions to the doctor, and he could basically travel to someone's home and make an x-ray, do a diagnosis, do surgery if need be, treat the person afterwards, and all with just a single suitcase. To apply the currents to the body from the Tesla coils, the current was diffused through glass electrodes, and these were basically Geisler tubes that would conduct the electricity to different parts of the body. And these were, for example, dental tubes, and they would conform to all parts of the mouth in order that the various parts can be treated. They made electrodes for every body part imaginable, and even some unimaginable. The Tesla coils were the ideal power supply for X-ray machines. And after Coolidge invented his hot cathode tube, things changed a bit. But the technology for the Tesla-style X-ray machines was very valid. This tube still functions today, 100 years later. Basically, the Tesla coil would attach to either end here. And then the radiation would come perpendicular to the target seen there. And basically the path that would be x-rayed would be, the part that would be x-rayed would be in the path of these x-rays, and there would normally be some film on the other side of the patient that would be exposed by the x-rays. And at that time the biggest plus was that it was the safest method as far as surgery was concerned. Especially with tissues that were malignant, that had growths of bad cells. The Tesla coil would cook the cells, would cut them away, and would do so very neatly and very precisely, so that you didn't end up removing one cyst and causing another down the road from these cells spreading and infecting other areas. It wasn't painless by any means, and required a lot of anesthetics at the time, because as you can imagine, this type of hot sparks wasn't friendly with the tissues at all. You definitely, but it was better than being cut with a razor or better than the alternative at the time. This is what I would consider the closest machine to what Tesla himself was building. It's a single spark gap, tungsten spark gap, and there's a reactance coil which limits the current to the circuit. We'll start off with what's very low power. This machine actually could be operated continuously for hours on end with no problems. Nothing would overheat, the spark gaps wouldn't overheat, the coils wouldn't overheat. They were designed like a tank. So this Tesla coil is very precise. Every calculation was made. The transformer, every calculation was made. They're engineering marvels of the time period, and it's something that we could learn a lot from today, especially with Tesla technologies, because we can try to invent all we want with new materials, but until we actually understand the old machines, there's little point. We have to know what Tesla was doing in order to improve upon it, or in order to continue that work.